The arterial blood gas test is a diagnostic test that you'll see time and time again when you're on the wards. The ABG is widely used to monitor patients for acid-base disturbances, and as such measures blood pH, the partial pressures of carbon dioxide and oxygen, as well as the concentration of bicarbonate in the blood. The first thing you'll see when you see an ABG is a set of 3 lines. On top of these 3 lines, you'll see 4 different numerical values that are easy to confuse with one another. So in this video, I'm going to share with you my visual mnemonic to help you remember which lab values go where on an ABG. Welcome to my home. My laboratory. I'm a busy principal investigator of an even busier lab, and I'm going to spare a few moments to share with you a couple of my favorite lab instruments. We'll get back to why these lab instruments are in the order that they're in later. But for now, just focus on the first object I'm holding on my left. It's litmus paper. And what's litmus paper used for? Well, it's used for measuring acidity, or pH, of a substance. That's why litmus paper is also known as pH paper. And the pH paper here should help you remember that pH is the first item on our ABG. I've used pH paper tons of times. I need to use my right hand to grab a reagent, and I'm purposely using my left hand to hold this litmus paper. Because holding the pH paper doesn't need a lot of dexterity, and I'm right-handed, like most people. pH occupies the leftmost spot in the ABG, which you could remember as the pH paper in my left hand. As I'm sure you already know, the pH is a measure of acidity, with a scale ranging from 0 to 14. Generally speaking, the normal pH for blood ranges from 7.35 to 7.45. Changes in blood pH are important to monitor, since deviations can help you determine whether a patient is in acidosis or alkalosis. So what was I measuring with the pH paper anyways? Whatever it was, it needed to be kept cold. Take a look at this box full of dry ice over here. Yeah, this dry ice keeps things real cool. But recall the main ingredient found in dry ice. That's right, it's carbon dioxide. As you may already know, dry ice is the solid form of carbon dioxide and is used primarily as a cooling agent. You can really see all that gaseous carbon dioxide rolling off the dry ice. By the way, this dry ice should help you peg the next value measured in the ABG, carbon dioxide. Well, actually, it's the partial pressure of carbon dioxide, or PCO2, which happens to be a surrogate for the carbon dioxide concentration in the blood. I won't get into the nitty-gritty, but the normal range for the partial pressure of carbon dioxide is about 35 to 45. The reason why carbon dioxide is included in an ABG is because CO2 is essentially converted to hydrogen ions, which can acidify the blood in excess. Therefore, PCO2 is a surrogate for your lungs' contribution to blood acidity, which can increase when the lungs aren't working. Make sense? Now, let's talk about this oxygen tank next to our fume hood. It should remind you of, oxygen. This oxygen tank should help peg the next value measured in an ABG, called the partial pressure of oxygen. And of course, oxygen is found on the right side of carbon dioxide in the ABG. Just look at how this oxygen tank is on the right side of the fume hood. These tanks are always outside fume hoods, right? Like the partial pressure of CO2, the partial pressure of O2 is just the surrogate for the actual concentration of O2 in the blood. Generally speaking, the PO2 should be between 80 and 100. As you can probably guess, low PO2 is observed when the patient isn't getting enough oxygen. Shocking. Finally, shift your gaze towards the far right to look at the baking soda I'm reaching for. Earlier on in this video, I mentioned to you that I was preparing to measure the pH of a certain mysterious substance. Well, now you know what I'll be measuring. It's baking soda. And what forms a big part of baking soda? That's right, it's bicarbonate. The bicarbonate is here to help you remember the last value included on an ABG, the concentration of bicarbonate, or bicarb for short. The normal concentration of bicarb is about 22 to 28. Recall from your physiology class that bicarbonate concentration is regulated by the kidneys. Therefore, the concentration of bicarbonate can help you gauge the kidney's acid-base contribution. And there we have it, an explanation of an ABG. Let's do a quick recap so I can take a break from my experiment. The ABG is a panel of laboratory values commonly measured in patients to monitor acid-base disturbances. The first thing you'll see when you see an ABG is a set of 3 lines. Between these 3 lines, you'll see 4 different numerical values that are usually presented in a linear format. They're placed from left to right as follows. pH is the first on the left, with the partial pressure of CO2 next as the second value. The third value is the partial pressure of O2. The last and final value is the partial pressure of HCO3, and it's all the way on the right. And that's it for our video on ABGs. In time, you'll get so familiar with ABGs that all of this will seem like second nature. In the meantime, I hope this mnemonic was helpful for you to learn the shorthand. Until next time.